Hello, everyone, and welcome to Class 2 of 272 Summer CAD class. Um, my name is Phil Simonowski. Emily, do you have anything to mention or talk about or set up?
Um, I don't think there was anything that I had specifically in mind, but just always know that if you have any questions, email the Lansdale Catholic Robotics account, and either Phil or I will respond to you from there. And we will be uploading the Monday's class onto our YouTube channel shortly. So if you missed anything or you have any questions, you might be able to find answers for that from our previous class already. But my name's Emily. For those of you who don't know, I just graduated from Lansdale Catholic, and I have been a part of Team 272 since I was in 8th grade. So that's just a little bit about me. And yeah,
Perfect.
that's all.
Thank you, Emily. My name's Phil. I am an alumni of 103, current mentor of FRC 272 and 14133, Lansdale Catholic teams. I am an engineer. I design stuff and help designers design stuff every day at work. And yeah, I use SolidWorks and OnShape just about every day. So today, we're gonna actually get everybody into OnShape and get a little bit more familiar with OnShape. Now, I know the people from 2607. You guys generally use Fusion, correct?
We use Inventor for CAD.
Inventor. Okay.
We use Fusion for CAM.
Perfect. That's totally fine. A lot of these things are parallel. So although I'll be using OnShape as like our medium and like where our files are located, you can follow along with this stuff. And you very well may know all of this. I'm kind of starting from the ground up with the class because there's a lot of students here that have no background in CAD at all and really don't know where to start. But we will be getting into more advanced things later in the class. So
we will be hoping to switch to OnShape this year. I hope.
Okay.
We almost did it last year, but we'll see about this year.
Okay, well then if you want, because I'll be mostly teaching and using OnShape, you're welcome to kind of use this as like a trial run, like a low pressure trial run.
That's the plan.
Excellent. Perfect. Then you're in the right place. So today we're gonna actually get everybody into OnShape, and if you haven't already, start to open it up. We're gonna learn about the interface and the file and document management, and learn about part studios and assemblies, feature tree, and kind of just where things are and where things are located. Last class, one of the learning pathways within OnShape that I suggested was, I believe, like the OnShape interface kind of, or introduction to OnShape specifically, document control. Hopefully that was helpful for those of you who did go through that little coursework. OnShape's tutorials are fantastic in my experience. In fact, I did something in the last class and I learned something just from taking one of the quizzes that I failed. No worries, London. Welcome back. And then we're gonna talk about constraints, both in how they exist in the real world and how we're going to apply them in CAD. As constraints are kind of the bedrock, the base. Understanding constraints is extremely important to making CAD models and sketches that make sense and are truly parametric. And then for our engineering conversation today, or our Cots conversation today, we're going to talk about fasteners. And I'm going to use a presentation from another team because I think they did a better job than I possibly could for that. And I'll give credit to that team when we get to that presentation. By the way, this I believe is FRC. I forget which team it is. but it's an FRC Teams robot that was completely designed in OnShape. Really crazy how easily you can make this kind of stuff and how quickly in OnShape. All right. So we're going to talk about files and documents in OnShape, and it's a little bit different than what you might be familiar with in other CAD packages if you use SolidWorks or Inventor. OnShape has a similar interface to Google Drive in terms of its overall file management. It has folders and it has documents within those folders. So you can put another folder in a folder. It's all web-based. It's all through a browser. And then the important thing to note is that you don't have individual files for each part. You have a document, a total document file. And within that document file, you can have part studios, which contain a single or multiple parts. And then you have assemblies, but that's all inside of that one document. And then you can have files on your own personal account or be part of a team, kind of like what we're doing in this course. The documents can also contain drawings, and you can actually upload PDFs and pictures and other things for reference inside of your documents as well, which is really cool. And inside of the documents, there's another kind of file management or file ordering layer system where you can kind of separate your parts into categories or break apart subsystems into different folders, stuff like that. And as I mentioned, this is very different from how it generally is in things like Inventor and SolidWorks, where you have a single part for every component. It kind of makes just managing all the files a little bit easier just to have them all in one place. And it also means that you can have parts that are made in a part studio that are affected by one feature. So if you change the location of a hole and it goes through 4 parts, you only have to change the location of that hole in one part for it to affect all of the parts. Kind of unique thing to OnShape that other CAD programs, they can do. You can do that in some cases, but in OnShape, it's kind of built from the ground up that way. And you can also insert components and parts and assemblies from other documents, other public documents that people have made. So I'm going to pop open OnShape here for a second just to kind of walk through the folder structure here. So as you see, it's extremely, extremely similar to Google Docs. So on your left side here, you have your main OnShape thing. You can go to all your recently opened files. You can go to one specifically created by you or specifically one shared with you. We're going to be working in this CAD curriculum team group. And I'll probably make a new folder for us. But right now, Joe is the owner of this folder, so I can't make a new folder inside of it. You can come here and you can create new documents and you can create new folders. And do remember that you do not need a new document for every part. You can make multiple parts and multiple part studios in one single document. I'm going to use this for reference. This was I mentioned this in the last class. This is like a design challenge that we competed in last year. I don't know where where are my tabs? Interesting that the folder tabs don't exist there. Oh, maybe they changed how they do it. Interesting. Interesting, they changed how they did tabs. So in here, I'll show you the overall assembly. The idea was that we created a robot that could pick up boxes and deliver them to people remotely. This was in kind of the very peak of the pandemic. So trying to come up with ideas to have a non-contact with people was pretty common and favored. So we made this cute little robot that works kind of like an eye robot, if you've ever seen one, or an eye chair, where the wheels rotate about a central axis, but they're also powered. So wheels can go like this, with the idea that this thing can go upstairs. And then it could pick up boxes, and then it could deliver boxes to individuals. And you'll notice that we have a specific part studio for the frame, where we have all the frame components, which looks like this. And then we have a part studio for all the drivetrain parts. So this is one file that has all of the drivetrain components built into it. It's not like the wheel is one part file and the plate is one part file and the standoff is one part file and this tube is another. These are all in one file. They're made in one file. So we could reference a geometry from one part onto another part. Super powerful. And then if I were to change the geometry or change the spacing, say on this gearbox mounting plate, if I set it up so that the sketches use the same reference geometry, if I change the geometry on one of the plates, it will carry it over onto the other plate and make it exactly the same. So there's much less likelihood for misaligned holes or other problematic design things you run into once you make the parts. So OnShape did change how it manages tabs. They used to be down here on the bottom, but they are not there anymore. And that's okay. Just something we got to get used to. So the folder structure is just then over here on the left. So this was our submission to the challenge. And this was the drivetrain, and this was the actual package handling, assembly, sub-assembly. It's a little lift gearbox. And these are all the parts for the lift gearbox. But I'll back up a little bit and explain the layout here. So up at the top, you've got this main bar where you can go to your OnShape home where your documents are, like we saw before. There's also this drop down with the 3 bars where you have all the different options to rename, or you can move the file or change the units or stuff along those lines. On the far left over here, there's a few things that are going to be important to us. One is comments. So you'll see I made a bunch of comments here in this whole project where I made comments about the design and pointed to specific areas about it and what needed to be improved or fixed. And then there's also versioning. OnShape has built-in version control. Most other CAD packages, it's usually another piece of software that you use or pay for that you are able to do version control on. What I mean by version control is you kind of save a snapshot of your design exactly where it is in that moment. And you can always revert back to it if you make some pretty awful mistakes. But you can also fork it. So you can go, oh, I want to add this feature to the thing. And then you could potentially merge it back later at a future point in time. It's very indicative of what's done in the software world for those of you that are more familiar with that. All right. So moving ahead, on the bottom left here, there is this tab manager. And there used to be the tabs on this bottom, like darker bar here. And you show the folders, but now they have this tab manager. And this is a folder structure. So what we're looking at now is the very top level components of this document, of this Robots to the Rescue document. So at the top level is this PDF, the actual full assembly. We actually have a design calculator in here. I have to give it permissions. It's been a while since I've been in this document. So this is a link to a calculation spreadsheet, and the spreadsheet, we're accessing this inside of OnShape, and we can type things in here and actually edit this as if it were just a regular Google spreadsheet. I mean, it is a regular Google spreadsheet. We can navigate to it by using this open link button. But you could also get to it right inside of OnShape. So you could put your design calculations and everything right into your document if you like. And then we put the whole rules and regulations web page directly in here too. So we didn't have to go and search for it. We could just click it right at the top level. And then we have an assembly that shows the stairs to show how it would potentially climb up the stairs. But then you can see in the drivetrain folder, if I click that little drop down arrow there, these are all the files that are within the drivetrain file folder. So for example, we have this drawing of the drive shaft. Let's see if it looks like my internet died for a second. Oh, there's the folder stuff. Whatever reason it wasn't showing before. So these are the folders, the same thing on the bottom that you see. But this was the drawing that we made of the shaft to describe the dimensions of it and how it might be made. So that's the tab Explorer, but you can also just navigate using the tabs on the bottom. And this is that same folder structure. It's just kind of flattened out to this bottom bar. If that makes any sense. And from this little plus button, you can create new part studios. You can create assemblies and drawings, new folders. You can also import different models and such. And then depending on what kind of a document or part studio or assembly you're located in, the next bar down from the top has all these different options. And they'll be different whether you're in a part studio or whether you're in assembly, whether you're sketching or whether you're doing something else. These are the features that we're going to use to make our stuff happen in CAD. These are the features that actually make things in CAD. And the number one most important one is Sketch. Sketch is used everywhere. I'm going to jump back here for a minute. So what I would like everybody to do is to create your own document. Now, Joe currently is the owner of this folder, so I don't think we can do this last part of it. But I would like everybody to get into OnShape and create your own document and just name it with like your first name and just name it with your first name. That's fine. Just so you can get familiar with creating a document. Who do we got? Michael and Chris. Do you have OnShape accounts yet?
Yes.
All right, cool.
I just created one. So.
Yeah, it's pretty easy. In the last class, we went through that. So, but I'm glad you were able to figure it out. So create a document, and we're going to use this opportunity in creating a document to learn about navigating in OnShape too. Not just where the buttons are, but also like how to rotate versus how to pan versus how to zoom. So has everybody been able to create a document? Anybody having trouble with creating a document? All right, cool. Excellent. So everybody, if you just made a brand new document, you should be seeing the exact same thing that I see on my screen. And before you do anything else, arguably the most important thing to know how to do is how to look at what you're doing in CAD. So you want to be able to rotate around your model or pan your model or zoom into and zoom out of viewing your model. And looking at specific planes or specific directions. And this can be done in a few different ways. Depending on your settings. So I have my settings to be just like SolidWorks, because I'm most familiar with SolidWorks movement stuff. But I think in OnShape, if you hold the right click button by default and you move your mouse, it will rotate around. Can somebody just verify that right click is the right button?
Yeah, right click does it.
Cool. Okay. So yeah, if you hold right click down and move your mouse, you see that you'll be able to rotate around your model. And sometimes it's not really quite intuitive how the model is rotating, but just use it a bunch and you'll get more familiar with it as time goes on. Now, if you scroll your middle mouse wheel in or out, you will be able to zoom in or out. And the important thing to note about this is that it will zoom where your mouse is. So if I put my mouse in the corner over here, it zooms a lot differently than if I put it right on the origin. So keep that in mind when you're zooming in and out on things and mousing around. It's very common for people to get lost in CAD. And what I mean by that is maybe you come over here and we rotate such that, or zoom such that you can't actually see where your origin or where your planes or where your parts are anymore. Like right now, this is just white space, right? Like it looks like there's nothing. If that happens, if you double click your middle mouse button in quick succession, it'll bring you back zeroed on where your parts and stuff are. That exists in most other CAD programs too. Like I know that's in SolidWorks. I'm pretty sure that's in Inventor, because it is not too uncommon to get lost. So just take some time, mess around, rotate around, get familiar with rotating around your thing using your right click button, using the zoom in and out, and then pan for you on the standard. I think pan is this if you hold the center mouse button down. Can somebody verify that for me? Pan is not rotating but moving like this.
Yeah, that works.
Is that the middle mouse button?
Yeah.
Okay, cool. If you're using the SolidWorks default controls, you have to hold Control and hold the middle mouse button to do that. And then Shift and middle mouse button zooms for me. I don't know what that might be. Shift and right click. Try Shift and right click. Let me see. Keyboard shortcuts. Yeah, not sure which one does that, but anyway, you get the idea. You can navigate around. Is anybody having any trouble rotating around their document or seeing stuff? Okay, good. Another really quick and important one to know is viewing normal to. So let's back up from CAD for a minute and talk about what normal means. I'm definitely not normal, but if I put my finger flat up against my hand, my finger is normal to my hand. Or if you take a pencil and put it straight up on your desk so that it's at a 90-degree angle in two directions, that is normal. So when we're looking normal to a plane, it basically means we're looking straight flat at that plane. And you can click on any surface, right click on it, and click View Normal To, and it will send you to the view that is directly normal to that plane. If you are just using the left, top, or right planes, you can use the View Cube up here in the right and just click on the left, or click on the back, or click on the front or top. But a lot of times the surface that you want to view normal to isn't one of those primary planes. So you have to click on the plane, right click, view normal. Or there is actually a shortcut to that, and that shortcut is the letter N. N is in Nancy. And if you click N again, it'll flip your normal. You'll be looking at it from the back side if you were looking at it from the front side before. So that's useful. I very much suggest getting familiar with using that shortcut and many others. If you're curious about what the shortcuts are in OnShape, you can click the question mark up here on the right, and it's got all the keyboard, literally every keyboard shortcut in the whole program listed out right here. So where we're looking at is N key, 3D view, and view normal too. That's probably one of my most used shortcuts. All right. So everybody's able to navigate and look around and mouse around and see their model space now. One important thing to note is that on the left here, and I think this is where I'm going with next. Yeah, so we're going to start talking about the feature tree next. The feature tree is where all of the things that you do or add to your model are shown to let you know what you've done and what the current progress of your part is. So if you look on the left in a part studio, you see that in a brand new part studio, we'll have these 4 features already built into it by default. You can't get rid of them. They're just there, and you can use them. You can ignore some of them, but you need to use at least one of them, and that is the origin, which is basically the very center of everything. The top plane, which intersects with the origin. The front plane, which intersects with the origin. And the right plane, which also intersects the origin. And these are your 3 main coordinate planes. And I generally suggest sketching in how these are described. So for example, if I wanted to make a profile of myself, I would probably draw that sketch from the front, if I was doing a profile from the front, on the front plane. I wouldn't do it from the right plane or from the top plane. That wouldn't make sense. And we'll go through more about that. As I mentioned in the last class, in robotics specifically, we want to use the top plane as the surface that's considered the floor for the most part. Not in every assembly, not in every part, but when we're drawing like layout sketches and trying to figure out the overall shape and size of robots, we want to use the top plane as the floor. Cool. So we start out with the origin, the top, the front, and the right planes as our very first features, even though we didn't do anything to them. And then from there, we can add sketches and features to our model space. Let's talk about the feature tree in general for a bit before we start making anything. Order is really, really important in the feature tree. For example, if you make an object and then you add like a bevel or like you cut off a portion of the object, right? You need to do it in that order. You need to first make the object and then cut away something from the object. If you take the cut away feature and put it above the make an object feature, it's not gonna know what to do. You're trying to cut away something that doesn't even exist yet. The order in this very, very much matters. But what's really powerful is that you can reorder which features happen when. So maybe you make an object and then you add a little bevel to it, and then you make another like extension on that, like a bar or something that comes out of that object, and you want to add that same bevel to that new surface. Well, instead of making 2 bevels, you can pull that bevel to the bottom after you made the second part, the second piece, and then apply the bevel to the 2 edges. And that way you only have 1 bevel feature. And they don't use bevel. It's called fillets in here, but sometimes bevel just makes more sense. As I mentioned, these can be rearranged, and they can be rearranged at any time in the progress of the model. And any feature in the tree can be modified at any time, which means that you're kind of like a time traveler in this. You can make something, and maybe you don't know what all the dimensions need to be or what they should be, but you just make it into the general shape that you think it'll work. And then as you get further and further in the design, you realize, oh, well, that 3-inch opening needs to actually be a 4-inch opening. Well, you don't have to delete everything you already did. You can go back to that original sketch and change the 3-inch opening to a 4-inch opening very, very easily. You can have multiple features that use a single sketch. So maybe you have one sketch and you have a triangle, a circle, and a square in that sketch. You can use one feature to make a pyramid out of the triangle. You can make another feature to make a cylinder out of the square, and you can have another feature to make a sphere out of the circle, all using that one single sketch. And there's other better uses of that we'll get into later in the course. You can also define variables. Variables are actually a feature in the model space. So I'll just show you this little X thing up here is a variable, and we can add a variable, and maybe I want to call this length, and maybe I want it to be 10 inches. Now use that value of length in any sketch that I make or any feature that I make that uses length as a variable. And then if I want to change the length of that thing at a later time, all I need to do is come in here and adjust that. Maybe I want it to be 50 inches instead of 10 inches. So again, we can add features, we can reorder features, we can have features reference different features. You got to be a little bit careful, and it'll make more sense when we actually start to model things. Moving on, I mentioned this before, you can create multiple parts in one feature and one sketch. You can have one sketch that makes multiple parts. And I also call this the parameter navigator, or the feature navigator, because it tells you how exactly your part was made, step by step, feature by feature. Any questions so far? All right, cool. If anybody's lost at any time, just stop me, and I'll happily go back. All of this will make more sense as we get more specifically involved into OnShape. Now, the probably arguably the most important thing in CAD is knowing how to make good 2D sketches. Even though it's 3D CAD, every single part that you make will in some way use a 2D sketch to define it, whether it's its overall shape or whether it's the path that it follows. And in 2D sketches, you need to use things called constraints. So I wanted to talk about constraining a little bit. In a more kind of just definitional term, a constraint is something that limits the movement of some object. And that's exactly what constraints in CAD do. If you just put a point on a plane, which would be as if I came onto this sketch, maybe I made a new sketch on the top plane, and I just put a point down in space, and this point has no constraints, I can pull and drag this point anywhere, can move whichever way. And maybe I don't want it to be like unconstrained. I want it to be in a very specific position. And generally for sketches when we're CADing, it's very important that your sketches are fully constrained, in that none of the elements in the sketch have any ability to move. We call this degrees of freedom. So in 2 dimensions, which is like our 2D sketch here, this is a 2-dimensional sketch area. It's just a plane that we're putting lines and curves and splines and points on. In 2 dimensions, there are a total of 3 degrees of freedom. And that is translation in the X, you can move up and down. Translation in the Y, you can move left to right. And rotation, you can rotate that object on that plane, just in the C axis, which is about the Z axis. Now, when you get into 3 dimensions, you actually have 6 degrees of freedom. So you can travel in the X, the Y, and the Z. Your good old right-hand rule, if anybody is familiar with that. And you also have rotation about all 3 of those axes. And that creates your 6 degrees of freedom. So we're generally going to be focusing on the 2D, 3 degrees of freedom situation when we're talking about sketching. We're going to try to eliminate all degrees of freedom for all sketch elements in our sketches. And there's many, many different ways to do this. There's no one right way. You will make mistakes with constraints, and you will need to delete constraints or add constraints. So it's important that you get familiar with them. And for those of you that use whatever other CAD programs like Inventor, you will already be quite familiar with all this. So let's talk about some examples here of 2D constraints. Let me present this just so it's a little bit bigger. To fully constrain something, it needs to be in a position where it has no options of directions to move. So a good simple example is like if you just took and you made a square out of like Lego pieces, you can take that square, that rectangle, and you can make it into like a rhombus kind of shape. Like you can twist it and bend it a little bit so that it's no longer a square or rectangle. But if you made a triangle out of those same pieces instead, that triangle is fully constrained, and you can't change the relative position of each of those pieces to each other. And here's some more examples of constraints. So this triangle up in the upper left here, this is known as under constrained because you can still take that triangle and rotate it between those 2 pins, right? You can take the whole thing and rotate it, and you could see that the triangle would move there. This center top triangle is over constrained because there's too many things telling it to be in position. If you try to align it with the 2, you'll conflict with the 3rd, no matter which way you look at it. And I'll explain that more in CAD. It's like telling something to be in one place and at another place at the same exact time. Like you can't do that, and the system won't allow it. And then we've got the one on the right here, which shows a exact constraint where you have these 3 pins that are aligned. So if you didn't have this nesting force, you could slide the triangle out or pull it down, but the nesting force just holds it into that constrained position. And I'm not going to go through every one of these examples here, but I think generally we get the gist of this. It'll make more sense once we get more so into CAD. These are the primary constraints that exist in OnShape and most other CAD platforms. The ones that I have in bold are the ones that are by far the most used and referenced, with the only exception being like maybe perpendicular and parallel should be in there, but I generally try to make other constraints besides that if it makes sense. And generally speaking, dimensions, which a lot of people go to first when they're making constraints, They should be your absolute last resort as a way to constrain a sketch. So in other words, if you are if you just start a sketch and you make a rectangle, and you want it to be on the surface, on the, like the top surface or right on that origin point, you don't dimension it as 0 from that origin point. You set the base of the circle or the rectangle as coincident to the origin point. And then you only want to dimension when you need to dimension, and as few dimensions as possible. I think my favorite constraint, in all honesty, is the equals constraint, because you can make really, really cool tools that will automatically space things an equal amount for you. Or if you need 10 holes in a surface and you need them all to be the same size, you just select them all, you hit equals, and it makes them all the same size forever and always. You only need one dimension to define however many holes. Super, super useful constraint. So ones you'll be familiar with are concentric, parallel, horizontal, and vertical. Not everybody quite understands tangent, but imagine tangent is like, I have a water bottle here, right? Imagine tangent is when the water bottle is just sitting on the surface. It's only contacting the surface of the water bottle at one point. That's tangent. And like if like the bevels on, this is my phone here, the corners of my phone, these are radiuses, right? This line is tangent to the radius, which is also tangent to this line. So that's another example of tangent. Any questions? Anybody lost or confused? Maybe I'm saying things that you already know, and that's okay. But this is a course to kind of get anybody familiar with CAD. So we're going to start off a little bit slow, but we're going to accelerate pretty quickly here. So now we're going to get into OnShape, and I want everybody to kind of get a little bit familiar with it. So I'm going to walk through everybody just starting a sketch, but your general exercise is going to be sketch some kind of closed shape. It could be as simple as a circle, but the caveat is that it needs to be fully constrained. Now, OnShape automatically colors all lines black if they're constrained, which is a good visual indicator. If you're not colorblind, of course, a good visual indicator that the object is constrained. And I have these two challenge components, which is use at least 6 different constraint types to create your closed shape. And then I have another challenge, which is quite difficult in some cases. Create a fully enclosed sketch using a sketch pattern. And I haven't even told you about sketch patterns, but they exist. When you're making a sketch, you can make a pattern. It's a little bit confusing, but so I'll walk through what making objects in a sketch, or let's just start from scratch. So follow with me just for a second, and then you can go ahead and do your own. I'm in my blank part studio. All I have is this dimension feature, or this variable feature. If I wanted to make a sketch, I have to first click the sketch button and then decide on a plane where I want the sketch to start. So for me, I want my sketch to be on the top plane. And so this window right here is the parameter window. You can rename your sketch here or any feature. You can change the plane that your sketch is defined on. So I chose the top plane, but let's say, I don't want to do the top plane anymore. I want to do the front plane. You can click in this little box and then click the front plane instead, and it will switch it out for you. It'll switch it from top to front. Or maybe I want to do it on the right plane. So this box here is like an input box. This is your choosing surfaces or points or whatever to input into creating a sketch and defining where your sketch is going to be made. There's lots of features that use input boxes like this. But I'm going to stick with my top plane. And I'm going to click the N key for Nancy to go normal to my top plane so that I'm looking directly straight down on it. And so now I'm in my sketch. I'm looking at the plane where my sketch is, and I have all of these tools up here on the left to make different lines or objects. And then I have a few other tools where you could make text, or you could offset lines from existing geometry, or you can make a fillet in the sketch. You can take a sharp corner and make it a rounded corner. You can mirror sketch items. I could pattern sketch items. And then after that, you see all the constraints that I talked about. So these are all the constraints over here. So you've got dimension, coincident, concentric. And in OnShape, it's pretty cool. If you mouse over any one of these, it'll give you a little bit more details about what they mean and what they do. So I'm in my sketch. I'm going to just start with a line, and I'm going to start with a line in space. And if you keep clicking in different places, it will automatically just continue this line until you end up on another point. I'm going to end up on this point. Now, OnShape will make some assumptions about the constraints that you intend to use. So you've got to be a little bit careful, because it's going to say, oh, this point is directly across from this point, so I assume you want those 2 points to be horizontal from each other. And that's what that little symbol there means, that horizontal line. So I didn't tell it to make a horizontal constraint, because I put this point just about horizontal from that other point. It assumed that I wanted it to be a horizontal point. And you got to be a little bit careful with that when you're sketching. Sometimes OnShape will make assumptions about things that aren't what you intended. But you can always come in here. If you mouse over near the place where those constraints are, you can just click that constraint and delete it. If I didn't delete it, I just hit undo. Those 2 points are going to move up and down together. You see they're directly horizontal from each other. But if I do delete that horizontal constraint, this point will now move independently of that point. All right. Any questions? All right, cool. Go ahead and mess around. I'm going to give everybody just a couple of minutes here to just go have fun and make sketches. One more thing you will notice when you do finish a enclosed sketch, it will be dark. It will be slightly darker in the center, and you'll be able to select the whole closed area. So, for example, if I click this line and delete it, it's no longer dark in the center, and I can no longer click and select inside of there. But if I click and drag this line to that point, that area suddenly gets dark again, and I can click on that. And it looks like OnShape also assumed I wanted a vertical constraint here, and then I wanted a perpendicular constraint here. And what else did it assume? I think that's it. All right, cool. So yeah, go ahead, sketch around, have some fun. Just make some kind of closed object. And make sure that when you finish your sketch, you hit the green checkbox. If you hit the red X, it'll delete everything you just did in the sketch. So make sure you hit the green checkbox, and then you will have your sketch. And then you can kind of rotate and look at your sketch, map it. view it from different angles and see if it's what you wanted to sketch. Let everybody have a little bit of fun with that. All right. What problems are people running into? Because I'm sure people are running into problems. Anybody having any issues with certain things? Does anybody see any red in their sketch? Raise your hand if you see red. You get bonus points if you get red. Nobody's gotten red yet. Wow, that's surprising. Well, I'm gonna make some red. I'm gonna make 2 lines perpendicular, and I'm gonna make those same 2 lines parallel. Oh, well, that's not possible. I'm asking those lines to do 2 very different things. It's impossible for 2 lines to be both perpendicular and parallel. So that's an example of a sketch conflict, is what it's called. Or in OnShape it says the sketch could not be solved. So what you need to do in those cases is figure out which constraint is causing the conflict, which is both of these are at this point. Decide which one you want to actually keep and use, and delete the other one. So I don't want these lines to be parallel. I just want them to be perpendicular. And now wherever I bring this line, it will always be perpendicular to that other line. Now I'm going to go and start to try to make this fully constrained. In fact, I'm going to delete a few of the lines out just to make it a little bit more simpler. Go like this. Cool. I'm going to put this point on the origin just because, no specific reason. I'm not drawing anything specific right now. I'm just using this as an example. And maybe I really like the angle that this thing's on. Or maybe I think these two sides should be equal to each other. And maybe these two sides are, or maybe this one's vertical. So slowly, by adding these constraints, I'm limiting the motion that these points and these lines have. Maybe I want these two to be perpendicular too. Maybe I'm at a point now where I want to dimension it. There's no more constraints that I can add that will make this shape that I want to make without putting a dimension on it. So I'm going to make this 30 degrees. I'm going to make the whole thing 6 inches tall. And I'm going to make this line horizontal. What constraints do I still have? I'm going to make this side, and this side equal in length. And now the whole thing just snaps into a specific position and all the lines turn black. And that means that it's fully constrained. And if I wanted to, I could go in and change these two values that I put in there now. It'll basically just scale it up for me however I'd like. Does anybody have any questions? Does anybody have any red yet? I'm telling you, I'll be impressed if you can get red in your sketch. All right. Was anybody able to use at least 6 different constraint types in your sketch? Nobody wanted to do the challenge. 0 people. Okay. All right. How about, was anybody able to use a pattern to do their sketch? Can everybody hear me?
I can hear you, but I've already done CAD before, so I feel like it's cheating.
Okay, all right, that's fine. That's fine. Yeah, I'm more talking to the other people, but I do appreciate you letting me know that you can at least hear me. Sihan, were you able to make a closed shape?
Yeah, I do.
Cool, perfect. What do you want to share your screen? You could show us your shape.
Sure. Hmm.
Oh, perfect. Look at that.
I just started this, but this is completed.
Nice. Well, is it completed?
I'm not. It looks like completed to me.
All right. Remember, when we're drawing stuff in CAD, we generally want to fully constrain it. So can you move any of those lines? If you clicked and dragged them. You're in the dimension tool.
Oh.
So do you see how? Yeah. Do you see how you have that selected? Yeah. If you click escape, you'll be able to get out of the dimension tool.
Like that?
Yes. So we're trying to prevent that from happening.
Oh.
You don't want your house to change shape, do you?
No.
I mean, maybe you do. That would be pretty cool. So what I'm suggesting, or what I'm trying to get across, is when we're designing things, we want to make sure that we're making sketches that are fully defined, that they don't have any freedoms to get longer or shorter or twist or anything along those lines. And when possible, we're going to try to use constraints. So maybe a good one. Do you want your 2 windows to be the same size?
Yeah.
Cool. So what I would suggest is click the lines on both of the tops of the windows. Yep. Click that one and that one. And which constraint do you think you would use to make them equal?
Equal?
Yes, exactly. It wasn't a trick question. So hit equal. And look at that. You've got 2 windows that are the same width. Now do the same thing for the height. Yep, just select any one of the sides. Equals. Good. Now, do you want your windows to be at the same elevation in the house? Like, do you want one window to be like at 6 feet high and another window to be at like 3 feet high?
At the same elevation.
Okay. So right now, if you dragged one of those windows, I click and drag one of them.
Like this.
Yeah, click and drag that somewhere. So your windows they're kind of lopsided windows now, right?
Okay.
So to get those to be on the same level with each other, do you have a constraint in mind? Do you think you could use?
Parallel?
No, those lines are already parallel. Right? Like the tops of the plane, the tops of the windows are already parallel to each other.
Hmm. I'm not sure.
Okay. There's actually a few different ways to do this, but what I would probably do in this case is the horizontal constraint. So I would select one of the corners of each of the windows. Make sure it's the same corner, relatively speaking. Click out of the object first because you have 5 other things. Yeah, click up. There you go. Now select the 2 corners. And you can do a few things, but if you select both these points, you can use the horizontal constraint. Yep. Now, if you move one of those windows up or down, it will move the other window up or down. There you go.
Why is the door moving as well?
Why don't you figure that out? Mouse over the door, like the points in the line over the door. You see the parallel that's there?
Uh-huh.
So it's not quite that one. Mouse over the points on the corner. Ooh, like yeah. What's that one? Ooh, there it is. So if you don't want the door to be at the same level as the top of the door to be at the same level as the bottom of the window, then you can select that horizontal constraint and delete it. Yep, click right there and hit delete.
No, is it this?
Maybe try that.
Ah,
there you go. So now you can move your door independent of your window. Oh, you have to select one of the corners. Yeah, now move that.
Oh.
Now, what's another thing that you haven't defined on your windows? You just showed it to us.
The size?
Yep, the size of the windows, or the size of the whole house, really, but the size of the windows. So I'm going to let you keep constraining, but you get what I'm getting at, right?
Yeah.
I want it so that you can't change any shape or size of this house, that it's a fixed size. You're going to need some dimensions, but you're primarily going to be able to do it with constraints. Okay?
Okay.
All right, keep going. Would anybody else like to share their sketch? This is actually a good example, so you could watch other people where they're sketching and what issues they're running into. If not, I'm just going to start picking on people.
My sketch is very boring, but I think I got to the 6 constraints.
Cool.
So I used
equal,
I used coincident, horizontal, perpendicular, vertical, and how many was that?
I think that was 6. Can you share? You want to share?
Yeah, but it's like very boring.
That's okay. We're not trying to make like We're not trying to make crazy stuff right now. We're just trying to learn how CAD and sketches work. Okay, it can be boring. It's okay to be
Yeah.
boring.
Okay. So when I was constraining it, I just kept using equal, so it turned into looking just like a triangle next to a square, but before it was like a different shape.
Mhm.
But so I made the point coincident to the origin, and then I made this one perpendicular and equal to this one over here, and then I made this one vertical, this one's horizontal, and this one is perpendicular to this one as well. And then I think it was just this one became coincident, and then there was a lot more equals.
Perfect. That's awesome.
Yeah.
I'm gonna give you another, not really a challenge, but this what you just created is perfect because it's an enclosed shape, but it's actually two separate enclosed areas. Do you see how when you mouse over the square,
Oh yeah.
that it doesn't highlight the triangle, right?
Mhm.
And that's okay. This is what I was talking about, where you can
Yeah.
make one sketch that makes multiple shapes and parts. But I want you to delete the coincident constraint on that center point, on the bottom
Okay.
center point. No, not on the
Oh.
origin.
This
To the
one?
left. To the left.
That?
Not,
Okay.
Yeah, that one.
Okay. Yeah.
The one in the center there, that one.
Oh, this one?
Yes.
Oh, sorry. I
No,
was
it's
just-
okay. I'm not being clear.
Yeah, it's okay.
So now drag that point. Yeah, there we go.
Yeah. Okay.
And then you can bring the square back in line. Like click. Yeah, like do that.
Okay.
But
But
then
change
move that around.
Yeah. Okay. And then I'll change this one up.
Yep.
Okay. Do you want me to
try
do that right now or just like on my own?
Yeah, do it on your own. Like we don't have to watch you do it, but try to make it one single
Yeah.
range instead of two multiple ones. Perfect. Awesome.
After a point, I just didn't want to keep using like dimensions, so I just kept using equal, and then it turned into two very boring shapes. But
Next, if you want to make it less boring, try using an arc or a circle.
Yeah.
Or even a spline. Splines are actually quite difficult to fully constrain. Try to challenge yourself a little bit. Or you can take one of the corners of your square there and you can make it a radius, which is that sketch fillet button up there.
Okay. Sounds
Cool.
good.
All right. Who else thinks they have a completed shape?
So I have a face, but it's not finished, and I don't know how to fix it.
Okay. I'm sure your face is beautiful. It doesn't need fixing, but you want it to be fully constrained, is what you're saying, right?
Indeed.
All right, cool. You want to share your screen?
Sure.
All right, let's see. Okay, so anywhere that you see the blue lines,
Yeah.
you can click and drag and see in which ways they can move. Ah, there you go.
But what would I constrain that to?
So do you want that square to be centered, or that rectangle to be centered?
Yeah.
So there's a constraint called midpoint. I'm going to give you a hint.
This one.
Yep. What do you think you want the midpoint to be to?
This line here.
You could do it to the line, or you could do it just to the origin point.
True. Yeah. So
there. Nope, not there.
okay.
This is what. Let me explain what midpoint does. Midpoint makes it so that whatever point you select ends up at the center of whatever line you make. So as your line gets longer, that point is still at the center of the line. So the line gets longer in both directions.
Okay.
The point
So
will always
it'll
be the
center.
Yep.
Be this line.
Yep. And that one. There you go.
And
Perfect.
now I use 6 of the constraint lines.
Now you use 6.
Yeah.
All right, perfect.
Yep.
All right, next, I'm going to show you another cool one just while you're here. There's a trim tool. It looks like a pair of scissors. Do you see it up at the top? Left to the left. Further, way further. Looks like a pair of scissors.
Oh, yeah.
Yep. It's called the trim tool. So I'm going to give you the same challenge that I gave Emily. You have like 1, 2, 3, 4, 5, 6 individual areas, right?
Yeah.
You see that? I want you to try to make this all one area. And how the trim tool works, click on that center line. Just give that.
Which one?
Yeah, sorry, do the inner ones in the circle.
Okay, this one.
Yeah, not that, but the outer circle, that one. Yeah, click there. So it does exactly what it's called, right? It trimmed that line. It cut it away. And maybe this isn't what you want, but I'm just showing you how you can use this. So do the same thing to the other side. And then do the same thing to the line that goes across that's splitting the upper part to the lower part. Yep. Now I want you to notice something. Do you see how that broke your fully constraint stuff, right?
Yeah.
That's
Because it's
because... Sorry?
Because we centered it on that line.
Exactly. So we centered that point on that line, but we now just kind of deleted that line, right?
Yeah.
So I want you to think of another constraint that will help you center your lower portion.
Okay.
And I'll give you a hint. You have 2 lines, one on either side that could be the same. You took one big long line and you split it, and now you end up with one short line on one side and one short line on another side. That make sense?
Yeah.
So which constraint? Equals sounds about right. I'd say equals is good. Not
So-
that one.
No.
Do you see the 2 lines that I'm talking about that you made when you broke the other one? Yep.
These two.
Yep.
So equal these.
Yep.
Nice.
There you go. So now, because they're equal, if you change that number 5, it will always be centered. Change it to 7. Sure. See that? See how it extends in both directions?
Yep.
Perfect. All right. Good work. Who else? Would anybody else like to share theirs? London, Grace. Who is sorry, I forget the name, the first name of the person who is labeled as Maria Stumpf.
Oh, it's me, Ryan.
Ryan, perfect. Ryan, would you like to share yours?
Mine's like been bugging out like a lot. So
That's the
Not
kind of
really.
ones we want to see. So show
no,
it.
like I mean like the system itself. Like my computer's barely able to run it. So,
Oh, okay.
so
Do you have a
I'm trying it.
Chromebook?
I'm actually on a Windows right now, but it's just like lagging a lot. I should be
Hmm.
getting a PC this summer, so that should be better. But right now it's like barely running. So
Okay,
try to
okay.
fix that out.
All right. Yeah, no worries. And I'm sure like being on a video call doesn't help, probably, right?
Yeah, it's probably one of the main factors.
You can also just to let everybody know, you can call into this meeting. It'll be a little bit more difficult to see the stuff that I'm sharing on the screen. But you can call into it if that's easier. Like there's a number that you can call. But no worries. Good luck in getting your new computer. Just follow along, do as best you can.
Yeah,
Thanks for
I'm taking notes and stuff, so we're all good.
cool. Perfect. London, do you have something to show us?
I mean, like I made this heart-like figure, but I was kind of playing around with what are they called again?
Constraints.
Yeah, I was kind of just playing around with them and see what they would do.
Mhm.
So yeah, I mean, I can show.
Yeah,
I guess
please.
I'm a little confused on how some of them work, but I was kind of just playing around.
That's exactly what we're trying to work through here, because a fundamental understanding of these constraints is really important to making good CAD. Okay.
Uh-huh.
So please share your screen if you can, and let's see what's going on with yours.
Okay. Okay. Well, yeah. You see, I made like this heart, like
Oh, nice.
shape. Yeah.
You know, you could use an interesting constraint that I can help you with a little bit.
Okay.
You're going to use the symmetric constraint. I'm assuming you're trying to make a symmetric heart of some kind, right?
Yeah.
Perfect. So yeah, there's a constraint called symmetric. So you
Wow.
click the drop down, see symmetric. Scroll down. It's close to the bottom.
No. This one says curvature.
Up one.
This is fixed.
Symmetric. Up one
Oh,
more.
there it is. I was looking for a C, not an S.
Cool. So if you read that little explanation there, it says make two entities of the same type symmetric relative to a line, plane, or linear edge. So
Yes.
which plane is your heart going to be symmetric about? If you
The
rotate
front
around.
plane?
No, you're facing the front plane right now.
Yes. See, this I can never find the right click. I found it like once.
Wait,
My keyboard's weird.
Are you using a trackpad?
Maybe. I don't know.
Like on your laptop, like a little
Yeah.
CAD?
Yeah.
Oh,
Yeah. No,
CADing
it is
with a
touchscreen, but like the touchscreen's not working right now.
CADing with a touchpad is pretty difficult. Like I can't CAD with a touchscreen. If at all
Yeah.
possible, I suggest if you getting like a USB mouse.
Okay.
If not, no worries. I understood, but
1 second. Here. Do you have a mouse? He said he suggests me use a mouse.
everybody.
He said he suggests if I use a mouse because I have the touchpad, which is limiting some of the things I need to do. Yeah. Yeah, he said. Yeah. Yeah. Yeah, you can.
So yeah, like just
yeah.
In general, CAD is much easier when you're using a mouse.
Yeah.
It's not necessary. I've seen people CAD with touchpads, but it's definitely more difficult.
Yes.
I
think he's going to get a mouse.
So anyway, London, what you can do you see it up in do you see the view cube in the top right?
This?
Yeah. Click the arrow key to the right or to the left, whichever. Yep, keep clicking. Cool. So which plane?
Wait.
Okay.
It's on. Okay, what is it called though? Let me just one. Oh, my bad. Okay. That's the TV. This one. Yeah, okay. Yes.
Try again. Yeah, you can stop sharing.
Yeah, I know, but like, yeah. Let me. Okay, hold on. Oh my god.
All right. While London's figuring that out, would anybody else like to share? If not, we'll keep moving on. All right, cool. So hopefully everybody's able to get a little bit familiar with sketching. A little bit later on, we're going to try to be sketching more specific things. Right now, we're just trying to straight up just get familiar with sketching and constraints and stuff like that. It will be confusing at first. It will give you errors. It will seem like it's preventing you from doing what you want to do in some cases. But troubleshooting what your sketches are doing and why they're not working the way you want them to work is a good practice. So it's about 8:30 now. I would like to switch over to the kind of final portion of the class here, which is going to be our Cots review. And today, I know it's a very, very exciting topic. I'd like to talk about fasteners, so bolts and screws and rivets and stuff like that. And I'm specifically going to talk about them in the context of CAD as well. So let me pull up. I'm going to pull up this presentation. I mentioned earlier in the class that this was created by another team. It's created by 3005, the Robo Chargers. No idea where they're from, but they made some pretty awesome presentation content. So giving kudos to them. So fasteners, for those of you who most people are familiar with fasteners, but we use a few very specific ones in robots, and these ones are also very, very commonly found in other applications. So fasteners are pieces of hardware that join things together, and they can join any two things together, but generally their goal is to hold two different pieces together, or multiple pieces together. So you might be familiar with wood screws or nails or bolts or clips. Those are all types of fasteners. And threads are often a very, very common component of fasteners. Threads are basically an inclined plane around a cylinder. And what they do is they use a large amount of rotation to apply a really, really strong tensile force, compressive force on the object that they're holding together. Some fasteners do have threads. Many fasteners have threads, and there are plenty that don't. There are pins and stuff that don't have threads, or clips that don't have threads. And you can have internal or external threads. It's usually the combination of a set of internal threads and a set of external threads. They use in combination with, for example, a bolt and a nut to go and clamp something together. Let's see. In threads, in the inch system, or in the imperial system, thread sizes are defined by their outside diameter and the number of threads per inch. So, for example, a 1/4-20 bolt is the outside diameter of the bolt is 1/4 of an inch. Okay, so if you drill a 1/4 of an inch hole, a 1/4-20 bolt will go through it, just barely. And that 1/4-20 bolt, it has 20 threads per 1 inch of the length of the bolt. And that's known as the pitch, that 20 number. So generally speaking, as threads get smaller, their pitch gets finer. They get smaller and smaller pitches, more threads per inch. And then important to note in the imperial system that sizes less than a 1/4 of an inch are given sort of arbitrary numbers. Like, they generally decrease, but it just starts at 12, goes to 10, 8, 6, 4, 2, and 1. But above that, it goes 1/4 of an inch, 3/16, half, 5/8, 3/4, 1 inch, so on and so forth. It goes up by usually fractional inch increments, and the thread pitch will generally get larger as you get larger bolts. And the metric stuff is, in my opinion, a little bit more simple. Generally, metric threads are specified by their outside diameter of the thread pitch, just like the imperial stuff. But there's it's in metric. So this, for example, is oh, and by the way, it's not pitch, so it's not number of threads per inch. It's the distance that one thread is long. So, for example, an M3 by 0.5, it's a 3 millimeter outside diameter screw, bolt, whatever it is, and each thread is comprised of 1/2 of a millimeter. Like from the start of one thread to the end of one thread is 1/2 a millimeter. So that's thread sizes. We're going to keep them moving on. So we're going to talk about bolts and screws. In general, although they are used interchangeably, in general, bolts are threaded fasteners that are used with a nut, and screws are threaded fasteners that are installed into a threaded hole or form their own threads as they're installed. So we use both bolts and screws in FRC, but primarily bolts because we're using bolts and nuts. Cap screws are probably the most common type of screws. They have a head that's used to turn the screw, and then they have the threaded portion below the head. The cap just references that there's a surface above the threaded portion or the shaft, the shank of the screw. And we have socket cap screws. So these are a type of cap screw that has a socket that you put a tool into, in this case, Allen wrenches or hex wrenches. The internal hex is what you apply the torque to when you're tightening the screw. They don't always have to be hex either. They could be like a star or Torx, or sometimes you even see square ones on old school stuff. So there's a few different types of these, obviously: socket head, button head, and flat heads. They're used for different applications. Socket heads, you can do something called a counter bore, and you can get the head to be flush with the top surface. Button heads give you just a little bit lower of a profile of a bolt head. And then flat heads, you can cut a hole that has that kind of angled shape in them. And you can cut that hole into the part that you're screwing into, and it'll allow you to have the bolt head be completely flush with the top surface. And you could do that on thinner material than you can the socket head. And then we've got hex cap screws. So instead of an internal hex, these have an external hex. These are also known as hex bolts. Usually use a wrench or a socket to drive these, and they're generally larger in size. You don't find these in very, very small sizes, except in FTC, where we constantly rip the heads off of the little tiny hex screws that we have, which is very frustrating. So hex bolts are used a lot in the food industry as well, because there's no small cavity for stuff to get stuck into. Button head, like these socket head screws, socket cap screws, you can have like a piece of cheese or something that gets stuck in this hole that's really difficult to clean out. And then you get like moldy cheese in your bolts and in your machine. And that's a bad idea. Not as much of a problem in FRC, but just something to consider, that different bolts are better for different applications. Now, nuts. Nuts are internally threaded fasteners, and they usually go with a bolt. They're usually hexagonal, though they can be square, or they can be a D shape, or they can be a bunch of other things. And they're held with a wrench or a socket. We have plain ones. We have nylock ones that prevent them from counter-rotating. We have top lock nuts. Shoulder screws. These are probably my favorite type of screws, actually. They're a type of socket cap screw, but instead of just a regular threaded length of the shaft, they have a precision ground shaft on them. And this allows them to be used as a shaft for a bearing or other kind of pivoting joints. And the shoulder of it, and by shoulder I mean this little ledge right here, you can use to bolt down onto a surface so that this part of the screw is sticking up out of the surface. We've got all kinds of other stuff. Rivets. 272 got very familiar with rivets this year. Rivets are great because they're cheap, simple, quick, and they hold really, really generally strong, and they're easy to remove. They're generally quicker to remove than a similar bolt. Blind means that basically you don't need access to the other side of the hole to close off the rivets. Compare that to like a bridge rivet. Wait, let me see. Show you bridge rivet. There's like these guys. You've probably seen them before, any old bridges that you go across. They actually have a machine that you need access to both sides. There's a perfect picture. So what they do is they heat up that piece of metal, and then they use this as a big hydraulic press. And so this is not a blind rivet. This is a double-sided rivet. And they push it into the hole, and then they come and they press it until the rivet can't go anywhere. So that's a rivet. Where are we here? They're super, like I said, they're super easy to install and remove. But they do use a special tool to install them. Next, we have spacers, which believe it or not, are a type of fastener. They're just not one that holds things together. They're usually held to space things out. They could be round like you see. They could be square. They could be hexagonal. They're usually round on the inside so that bolts can go through them. They can be all kinds of different materials too. And then standoffs, they're different from spacers. Standoffs are internally threaded. Similar, they can be all different kinds of shapes and sizes. And you can use these to space off two things that you don't want to run a bolt all the way through. For the 272 people, we did this on the hood of the shooter. We basically made custom standoffs for the hood of the shooter for this past year. Each of those crossbars we threaded on either end to make a standoff that would space out the plates for the shooter. Any questions about this stuff? A lot of this, many of you probably already know, and I get that, but it's good information to know. We're going to get into more technical subjects as the year goes on. We're going to talk about gears and gear ratios and sprockets and all kinds of different stuff. But are there any questions about any fasteners? All right, cool. For the rest of the class, you're welcome to go and work in OnShape. I'll stick around until around 9. Make different sketches, make different things. As I mentioned on Monday, what I like to do is pick something up and just try to make a CAD model of it. So your phone's actually a really good example. There's a lot of different features on a phone that it's not just a rectangle, or it's not just a rectangular radiuses. You could actually make, a lot of the different profiles, or you could draw like the little camera bump out if you have one of those. Or in my case, I have a little fingerprint scanner there, or even the buttons on the side. These are all different things that you can actually model. And you don't have to put any specific dimensions on there, but just take your best guess in terms of what the sizes are. That's one of my favorite things to do to try to learn CAD, is just pick something up that I have on hand and go and draw it up. Cool. I'm going to open up the Learning Center here, and I'm going to suggest the next set of classes. I believe last week I suggested navigating OnShape and introduction to sketching. This week I am going to, or today, Wednesday, I'm going to suggest the next two, which are part design using Part Studios, and then multi-part studios. So on Monday, next Monday, we're going to start learning the different features that exist within OnShape to make individual parts. And this will be a really good foundation for that kind of stuff. This will omit a lot of the details that we're going to go into, but at least get you generally familiar with it. So does anybody have any questions? All right.
I have one if you have some time.
Sure. What's up?
What's something we should look out for if we switch to OnShape? There's a lot of cool stuff you showed off.
Yeah.
I know eventually MKCAD is also something people rave about. Is there
It's
any?
nuts. It's awesome.
Yeah. Is there gonna be like some? Oh, you don't want to use OnShape. It has, X.
Yes,
X
there
factor.
there is. And one of my biggest current qualms with OnShape right now is and I'll show it to you. I'll give you an example specifically. There is not an assembly level mirror.
Huh.
And so what that means is that you can't build the right side of your robot, just do a mirror feature and have it automatically make the left side of your robot. You kind of have to make both sides. Now you can kind of get around that and do some kind of like smart stuff. Like you can pattern rotate something, and maybe all your bolts and frame members and everything will line up. But it actually doesn't have a mirror at the assembly level just yet. So that's definitely like a gotcha in OnShape, that it's something that I wish that they did have. They do not. So a good example is here's 272's robot from last year. So when we were modeling this, we modeled the whole one side first, right? But then as we built the assembly, we had to copy all those parts and do all the same mates on the opposite side, which was just a little tedious. And for the relatively small assemblies that live in FRC, it's not so big of a deal. But like if I were to do this for stuff at work, not having that assembly level mirror would be a lot of work.
Right.
So that's definitely something to be aware of. Fortunately, there's a lot of ways in which OnShape makes it easier for you to deal with not having a assembly level mirror. So for example, they have a replicate tool that if you click on a part that has a mate on it, so for example, a bolt, a nut or something, and you click replicate and you click on a surface, it will fill every single hole of the same size with that bolt automatically. So it's not like you have to select each individual hole. You just click on the thing and it'll build the whole thing out for you, which saves tons and tons of time when you're trying to make fasteners accurate and everything. So I'd say that's the biggest gotcha in OnShape. No assembly level mirror. Other than that, there's really not many downsides. That is a significant one. I won't deny that. But there's really not too many other downsides to OnShape that I can think of off the top of my head.
Does it have a ANSYS like simulation?
I believe it does. That's in the App Store. So there's a whole app store for OnShape, and it's constantly being added to, and different companies provide new apps and stuff. So this is that app store. So this is OnScale. This is the one that that I've heard about, and this is you can get a free monthly usage up to a certain amount of calculations of mesh stuff, FEA and thermal dynamics and stuff like that. I personally never used this, but I have seen people use this, and my understanding is that it works quite well. So here's somebody doing a stress analysis on this kind of beam shape, which isn't too dissimilar from what you'd find in FRC. So you can see there's stress concentrations in this corner when they're bending this thing. And that's like native in OnShape. It's not like you have to export your model or anything. You just add the tab for that on scale, and you straight up. Actually, for this, I think you do have, it's a separate login. Let me see. I'm going to copy this over to my other page. Great question, though. Really great question. It's good to be skeptical of new software. Like anybody that tells you that any new piece of software or anything is like flawless, don't trust them because there's always problems with software. The not having an assembly level mirror is my by far currently my biggest qualm with OnShape, because it would save me so much time overall with assemblies if I didn't have to mirror everything.
I mean, not having like one tool is such a nothing compared to all the problems we have with Inventor. Like just having one student be the only one who can use the assembly on our team. That's rough.
That's real rough. That's extremely difficult. We had multiple times this past year where we had probably like 5 or 6 people in this document all looking at it at once and measuring things and figuring out what they needed to make and making drawings and stuff like that. It's absolutely huge in terms of actually making an accurate CAD model of a robot. So that's probably one of my favorite features of OnShape. And I haven't even touched on that yet in the class because I don't want to blow everybody's mind just yet. But you can have multiple people all in the same document making changes to it live at the same time. That's just crazy.
That's our biggest appeal, is that we've been doing CAD since like 2014, and since then there's been like one guy who's been the CAD person, and we're trying to make it a every mechanical student thing.
That's good. That's I think you're going in the right direction, really.
Yeah.
Okay, so here's on scale. It is a separate web page, but I believe if I create a project, I think you can link it directly with your OnShape account, import OnShape components from there. Let's do great. Anyway, I've not used it, but I've seen plenty of other people use it. There's a whole thread on Chief Delphi about FEA for FRC if you did want to learn more about it, where they do some really cool analysis on some of the profiles, like tubing versus extrusion versus like latent extrusion, stuff like that. And a few of our assemblies are broken here, but you get the idea. Oh, the other cool thing about OnShape, those libraries, all the parts have their weights made for them as well. So you can get really, really accurate center of mass calculations because thousands and thousands of hundreds of thousands of parts have already had their masses determined. And you don't even have to import a model of the field. One will just be there day one, available for everybody live.
Does this typically run well on a average laptop, not some sort of gaming or CAD laptop?
It will generally run well with fairly low spec laptops. This would probably be a struggle on those lower spec laptops just because there's so many parts and components here. But if you're just doing like, if you're just making some parts and making an assembly or two and bringing them together, it's quite capable. I've used OnShape on my own personal Chromebook, which is not like a high-end Chromebook whatsoever. And I have very little issue with running it without it lagging or stuff like that. A good internet connection helps because it is all cloud-based, and a strong and relatively powerful computer will make it process faster. Like, I'm assuming that everybody's watching me open these fairly large files pretty quickly. I have a pretty powerful computer, so I'm definitely biased, but I'll be honest that it does run slower on less capable computers. But if you're just making relatively small assemblies, I'd consider this on the borderline where it's starting to get big, and where it might start to struggle. But on a much more complicated robot than this, you probably need to divvy the assemblies up a little bit more and have like individual people work on the shooting assembly or the intake assembly or the drivetrain, and then bring them all together on a more powerful computer under the same assembly.
That's typically how we run it anyway. It's just split it up and
Yep.
make it a little easier.
Yep. So yeah, not really any difference to your current workflow, except that you could have multiple people working in the same document at once. Do you use GrabCAD or?
Yes.
And how do you like using GrabCAD?
It's the best we've used so far. So I was a student on the team from like 2014 to 2017, and this is my first year as a mentor. So I remember back when I was a student, we had like a bunch of like weird ones like Vault, Google Drive, and then there was like someone brought in a hard drive that we would all just plug into. None of them are even close to what OnShape can do. Constant issues. But GrabCAD is by far the best for Inventor.
Cool. Yeah. Nice. I just made a version because I want to show everybody how it works. You can go back in history to any point in the design. So I can literally show you the first time that I made a version of the robot. And I mean, it's for every portion of the document too. It's for the main assembly. It's for the drivetrain, the intake, all the things. You can go in at any point and see what happened at that point. Takes a minute to load, but it's pretty cool that you could see the progress. Cool. All right. Well, it's about 9 o'clock now. I will let everybody head to bed or do the coursework that we were talking about. Which, like I said, was the part design and multi-part studios. Really pay attention to the multi-part studio one because it's pretty powerful. Being able to design multiple parts in one place, all with the same contextual sketches. Really cool stuff that you could do out of that. But otherwise, I'll leave you go. Emily, do you have anything you'd like to say before we close?
No, I do not. Sorry.
Cool. A few quick things. I know it's a lot of like lecture and talking to at this point. Later in the course, we're going to be getting to more kind of interactive and designing things. This is kind of just getting everybody up to speed to be able to get to that point. So bear with us. Please let me know, as always, if you'd like to see something different, or if you want to learn about a specific subject. Feel free to reach out, and we'll make it work. We're flexible here, so. Yeah.
There was something else I wanted to mention. Sorry, I just remembered. But we're gonna start looking at the 2021 game design challenges and choosing games for you guys to design robots for in a couple weeks. So if there's anyone, like any specific game that you saw or one that your team did that you really liked and you want us to like you want to be able to design a robot for that, you can just email us with like the information about it so that we have it and we'll take a look. But that's what like you're going to be doing in a couple weeks. That's like the project portion of it, kind of. And you'll be split up into groups, and yeah. So look forward to that. I think it'll be really fun for you guys to like actually be able to use this stuff. So that's why going through and doing the little like the courses on OnShape, they're really important just so that you're able to do everything that you want to do with the robots later on. So if you have a game that you liked from last year and you want to design a robot for it, just let us know. But yeah.
Awesome. Thank you, Emily. All right. That being said, I think we're good for the night. Thank you, everybody, for logging on, and we will see you all next Monday.
Thank you.
Yep. Bye now.
Thank you.